The Greenland ice sheet is an incredible expanse of ice covering over 1.7 million square kilometers, and it is on average almost 2 kilometers thick. It holds a huge potential for sea level rise. We're talking about a total contribution exceeding 7 meters if the entire Greenland ice sheet were to melt. Quite staggering. According to the latest IPCC report, by 2150, the Greenland ice sheet will contribute by at least 10 centimeters to future global mean sea level rise. That doesn't seem much, but be careful, this is how it starts. In reality, this 10 centimeter rise will occur between 2050 and 2150. But why is the time range so broad? Well, actually, most of this wide time range is explained by the uncertainty of the future climate we choose. This will depend on how much greenhouse gas we will emit in the future. But the truth is that the response of the Greenland ice sheet to climate change is also difficult to predict. Unlike Antarctica, where the loss of ice is mainly due to melting by the ocean, resulting in increasing glacier speed and more carving of icebergs, Greenland is melting more and more at its surface. Why? Well, because it's warmer in Greenland than in Antarctica, but also because Greenland ice and snow surface is becoming darker, absorbing more sunlight, which in turn accelerates the melting, and so on. There are 3 reasons for this surface darkening. First, snow that starts to melt is darker than dry snow. So when the melt starts, the darker snow will melt even faster, and so on. Second, when snow melts away completely, it exposes bare ice that is even darker than wet snow. As the climate warms, larger and larger areas of bare ice that used to be covered by snow all year round are now being exposed in the summer melting season. And finally, because of blooms of pigmented algae that grow on the ice at the surface in summer, making it less white. Another very special process happening in Greenland is that the layer of old compressed snow covering the ice sheet that we call firn is acting as a giant sponge. At the moment, it traps around half of the meltwater produced at its surface, which then does not reach the ocean to contribute to sea level rise. But the sponge is getting fuller each year. Eventually, it won't be able to hold more meltwater, and the amount of runoff to the ocean will increase. When? Well, once more, it all depends on the future climate we choose. Either the sponge could rebuild itself, or it could slowly get saturated, accelerating ice loss from Greenland. The Greenland ice sheet has the potential to change the surface of the planet, but what happens locally is very peculiar. Intuitively, you might think that sea level rises everywhere in the same way on the planet, but this is not the case, because ice sheets interact with their surroundings, influencing local sea level.
Kalaallit nunaanni sermersuaq aakkiartortillugu nunarsuup imartaa sumiifiit amerlanerni qaffakkiartorpo. Illuatungaanili kalaallit nunaanni killarmuanik pusoqarluni. Umiarsuilueqarfinni illoqarfinni nunaqarfinniittunilu imaq ernumanartumik apparnerulersimavo.
Yes, you heard or read that right. Even though ice is melting, what the people see in Greenland is actually the sea level falling. But why is that? The Greenland ice sheet is on average almost 2 kilometers thick. We've seen that. It means its huge mass attracts water because of gravity, just like the moon pulls the ocean. As the mass of the Greenland ice sheet decreases, its gravitational pull is reduced and the water flows away from the coast, impacting the other side of the Earth with rising seas. This is quite difficult to comprehend, but it is a law of physics. So the water from Greenland will affect communities living a long way away. The bottom line is that the vulnerability of the Greenland ice sheet to climate change is a topic of great significance for sea level, both globally and locally. Its mass loss currently represents about 1/3 of the total land ice contribution to sea level rise. Other contributions come from smaller glaciers all over the world, and of course Antarctica. By expanding our knowledge and collaborating across scientific disciplines, we strive to better understand the vulnerability of the Greenland ice sheet and its implication for the future of our planet.